topics that we're going to be covering today are loci and constructions, and then sort of going on from that, we're going to be covering transformations and similar shapes, and then finally we'll be working on sampling. So, you know, geometry is the main theme of today's lesson. So the first topic we're going to be going through is loci and constructions. So here are all of the learning objectives that we're going to be covering. Very exciting. But before we get started, obviously, I need to know how you guys feel about this topic before getting started. So that helps me decide whether I need to go fast or slow, or, you know, maybe focus on exam questions a bit more if everyone's really confident. So please head over to slido.com and respond to the poll and let me know how confident you feel with the topic of loci and constructions. Don't worry, I can't really tell what you guys, who's voting for what, because yeah, I can't really tell. So make sure that you do actually put in your votes in, because otherwise, if everyone says they're confident and they're not really confident, I'll go through it really fast and it's not going to be a great learning experience. So make sure that you are responding honestly to it. Just going to wait a couple more minutes for those of you that are maybe struggling to get onto Slido. Hopefully we can get a little more than 10 responses, because there's more students in the class and I obviously want a good sample of the class to respond to the polls. Okay, another 30 seconds for those of you that haven't put in your votes yet to do so. Okay, so let me quickly close the poll. So we have an average score of a 3.3 and most of us are on a 1, which means that most of you are not confident with this topic at all. That's completely fine. I'm going to go through it nice and slowly, and hopefully at the end of the topic, you should be feeling much more confident with it. And obviously, if you do have any questions at any point, which you probably will do, make sure to post them onto the Teams Q&A, and we'll try our best to get them answered. Okay, so let me close this poll up and let's get started. Okay, so I'm going to go nice and slowly with this topic. Okay, so loci is essentially a word that's the plural of locus. It essentially traces a path, taken by an object in real life. You can think of it like that. So you can see we've got an example of a runner over here, and the runner is running along this racetrack. So, that's the locus of their path. Okay, so that's essentially what loci means. So the locus around a point. Okay, so usually this is a circle. So you can think of it as all the points equidistant from the center. So you can see here a clock, the hands of the clock, they rotate, right? And the size of the hand of the clock does not actually change. So every single time the hand of the clock rotates, the position where this end point of the hand is the same distance away. If it's here, it's the same distance away if it's here, it's the same distance away if it's here, same distance away if it's here, and so on. So around the entire circle, the end bit of that hand of the clock is the same distance, and this is known as equidistant, okay? So we can draw the locus around a point. In your exam questions, they might ask you to, draw the set of points that represent that are exactly 5 meters away from this point over here. In that case, you would pull out your pair of compass and you would put the pointy bit at your little center, and then bring out your ruler, take your pointy bit, place it at the 0, and then place your pencil bit at 5 centimeters. Then don't change the width of that ruler, place the sort of sharp bit over there, and then with the circle holding it firm, with the pencil holding it firm, you trace a circle by turning your compass around. Okay, so if you don't have a compass for this lesson, I would recommend you bring it out, bring a sharp pencil out, and we're going to practice loads of examples where we draw loci. Okay, so usually we use compasses to create a locus around a point. You don't necessarily need two, but one should do fine. Okay, so loci don't necessarily have to be a line. So I told you that when I said find the points that are exactly 5 meters away, this would be a circle of radius 5 meters. But these are only exactly 5 meters. If an exam question says, for example, find the set of points that are 5 meters or closer to the point, then this entire circle would be shaded, because this point over here, that's less than 5 meters away, right? Because this is 5 meters, it's closer than 5 meters. This point over here as well, less than 5 meters, this point less than 5 meters, this one exactly 5 meters. Using that strategy, you can actually shade every single point within that circle. So you would have, this entire area shaded. Okay, so you can see here, this is a lovely example of how, you can shade a set of areas, and that would represent a locus. So here we have a Slido question. So which of the diagrams shows an accurate locus of points closer to A than to B? So think about what this means, right? So think about, what does closer to A than to B mean? So look at each of the diagrams. The blue is a shaded area. Which of these shaded areas represents all of the points that are actually closer to A than to B? Okay, so have a look, make a decision on your answer, and I will open the Slido poll up in about a minute. So look at each diagram and think about which of the blue regions is the closest to A than to B. Okay, so hopefully that was enough time. Let me open up the Slido poll. So select the answer that you think is correct, A, B, or C. Just going to wait about a minute or so for those of you that are still waiting to put in your answer. Again, remember, if you haven't done so already, make sure to head over to Slido, either scan the QR code or go to slido.com and put your session number in, so 444129. It helps keep interaction in the lesson and also helps me see if you understand stuff or not. Yeah, otherwise I'm just going to assume, you know, everyone understands it, which is not going to be great for all of the students. Okay, so looks like we've stopped at 15 votes. Let's have a look at what everyone had to say. So most of you said A, and there were 13% of you that said C. So let's have a look at the right answer. The right answer is A indeed, so well done if you got that correct. I'll quickly go through the answers. Okay, so I need to show an accurate points of locus closer to A than to B. So let's have a look at, let's say C, because a lot of you said C, right? So let's have a look at this point here. This point here is shaded, is within the shaded region, so it's a perfectly valid point to choose. This point is closer to B than it is to A. So you see how these points, they violate the rule that I need to be closer to A than to B. You cannot have even a single point of that sort that violates the rule, right? So if I say it needs to be closer to A than to B, I need to make sure that every single point, always choose extremes, right? So I've chosen an extreme here. I've taken like that point there. That is so much closer to B than it is to A. Okay, so you can see there why that's not correct. For B, obviously no one said it, but I'm still going to go through it anyways. You can see that every single point is closer to B, right? This point here, it's much closer to B than it is to A. And like, let's take that one there. Now we're just, now we're not doing anything good, are we? Because this is such a long line. This is quite short. So that's definitely not the answer for A. Even like a point over here, again, as I said, take an extreme, right? So if I go here, then this point is still closer to A than it is to B because this line here would be longer. Assume it's a straight line. I can't really draw straight lines on the screen, so yeah. Okay, so well done for getting that correct. Let's move on to construction. So how do we actually construct this loci? So you've seen here all of these lovely diagrams. We're going to be learning how to actually construct these diagrams now. So constructions are essentially very, very accurate diagrams. They are usually done with a pair of compasses and a ruler. So make sure when you go into your exam, you have a pair of compasses and a ruler and a sharp pencil because you don't want a blunt pencil, okay? So make sure, so one very common mistake people make is that they rub out the construction lines. You are not supposed to do that. The examiner has to see the construction lines. It's not like rough work that you need to rub out and, make your work neat. That's not the way it is. You have to make sure that all of the lines are seen so that they can see your method in actually drawing these things, okay? So we construct a perpendicular point to a line. So you can see here I've got a line AB, and I want to draw, the line C, which is perpendicular to AB at the point D. Okay, so the shortest distance from a point to a line is obviously the perpendicular distance, right? So if you can think of it in this way, right? So if I take my point C, this distance here is definitely longer than this distance here. This distance here is still longer than this distance here. So you can think of it as Pythagoras theorem, right? So every single time you draw a line like this, you've got your little side here is A, little side B, and then this long side C. Pythagoras theorem says this is the longest side of the triangle. The only way you can minimize these set of lines is by going perpendicular to the actual line of interest, which is AB here. Okay, so we're going to be constructing a perpendicular line to from P to our red line, which we have on our screen. Okay, so you can see here that first of all, we start off by sort of opening your pair of compasses. So again, pull them out, put a pencil in. Just going to give you a couple of seconds if you haven't done so already. Okay, so hopefully that should be enough time. So essentially what we have to do is open up your pair of compasses such that the distance, the width of your compass is slightly longer than the distance of P to the line. So your pointy bit over here, your pencil bit should be somewhere over there. Okay, so slightly longer than than the line. Then don't change the width of your compass and rotate it so that you cross the line at 2 points. So one on this side and one on this side. So this is going to be F and E. We're going to label those points. Okay, so I'm just going to give you about maybe 20 seconds to have a go at that yourself. And just remember, once you're done constructing these points, don't change the width of your compass. Don't close it or anything. Keep the same width. Don't move it. Okay, so hopefully everyone's done that. Essentially, start with your compass, pull the pencil bit slightly away from the actual line, and then we're using the same width, just sort of intersect the line at 2 points using your compass. Okay, so the next bit that we have is we need to now put the compass at point E and draw an arc below the line. Here, it is essential that you don't change the width of your compass. Okay, so place the pointy bit at E now. Okay, and using the same width, just sort of draw a nice long arc of that sort. Okay, so that's really short just because it's in the diagram, but make sure you draw a nice long one just so you can see where it intersects clearly. Okay, so using the same width, put the sharp bit at E and then use the pencil to draw a curve at G using your compass. Then do the same thing at point F. So what you did at point E, do the same thing at point F. So your line will look something like this. Okay, so don't change the width. Again, remember, if you change the width, you're going to make a mistake. So now you have a new point called G. Next thing you need to pull out is your ruler, right? Place your ruler such that the ruler is along both of the points. So align the ruler along both of the points, okay? And all you have to do finally is just draw a line along those 2 points, right? So connect the points using a ruler, essentially. And that is your perpendicular from P to your line, okay? Always make sure you label your perpendicular with a nice right angle over there, just to make sure that the examiner knows, you know, what you're talking about. So hopefully that makes sense. That's a really quick example on how to actually construct a perpendicular line from a point. And we're going to move on now. Okay, so again, if you didn't get a chance to copy it all out or anything like that, remember you've got your recording at the end of the lesson and also this presentation that we're going through. So make sure to make as many notes as you want to at the end of the lesson. Okay, so whoops. Now we're going to be doing a few more examples on constructing the perpendicular from a point on a line. Okay, so very, very similar, except your point is now on the line. Okay, so you can see here we've got a lovely line and we've got a point Q on it. We need to draw a perpendicular that actually goes through the point Q. Okay, so again, get your compass out, and essentially what you have to do is extend it any distance, so make it really, really long. That would be nice if you can make it nice and long. So yeah, make sure that you sort of use the same width of the compass on this side to create an S and on this side to create a T. So I'll give you a couple of seconds to actually draw the S and the T on using your compass. Okay, so once we've done that, again, don't change the width of the compass. Put the sharp bit on here. So your pointy bit on here. Don't change the width of the compass and draw a nice arc below the circle. So it's not really aligning with what's drawn already, but draw a nice long arc using the compass. So once you've done that, again, repeat from point T. So again, put the pointy bit on point T and then draw another arc without changing the width of the compass. Draw another arc of this sort that crosses at a point V. Okay, so once you've done that, all you have to do is use a ruler to connect point Q and point V. So as you can tell, my diagram's not very accurate because I'm not drawing it with a compass. So yeah. Essentially, use a ruler, use a sharp pencil for all of these things, and connect the point Q to the point V. And that is your perpendicular to a particular point on line. Okay. So moving on, we have another Slido question now for you to define the shaded area. So the shaded area is this bit over here, so this blue dotted triangle. Essentially, you need to look at each of these points and see which one actually describes it perfectly. So read each of the statements and try and see if it matches what's going on in the triangle exactly. Okay, let me see if there's a picture on the Slido. Okay, there isn't. So, okay. I'll give you about maybe 2 or 3 minutes to have a read of this question, and then I'll open up Slido polls so everyone can respond to them. So again, read each and every sentence really, really carefully because even like a tiny word change can make a huge difference. Okay, maybe another minute or so for you to read every single sentence and match up one of the points to the shaded area. Okay, so let's open up the poll, have a go, and match the statement to the actual point. It's very interesting to see what everyone's getting because I can see what everyone's putting in over here. It seems to be an even split between everyone's answers. Okay, just gonna wait maybe another minute or so. So if you haven't put in your answers yet, please make sure to head over to Slido and do submit your answers. As I've already said, it's anonymous, so I can't really tell who's said what. I don't have any rankings or anything opened on this, so you should be fine even if you get it wrong. Okay, so let's have a look at what everyone had to say. So there's an even 50-50 split between all points are closer to AB than AC and are at least 1.5 meters away from the line AB. And the rest of you said the points are closer to B than C and are at least 1.5 meters away from the line AB. Okay, so those of you that said all points that are closer to AB than AC are at least 1.5 meters from the line AB are correct. So well done if you got that right. I can see the answers moving now. So I'm going to close the poll. Okay, so let's go through as to why this is the answer, right? So, okay. So first of all, let's read each of the statements. All points that are closer to AB than to AC and are at least 1.5 meters away from the line AB, right? So we'll look at AB and we'll look at AC, and yes, that is true, right? Because all of these points here are closer to AB than they are to AC because there's such a huge difference there, right? Between AB and AC. Even if I took, an extreme point over here, this point would be still closer to AB than it is to AC, okay? So, and it needs to be at least 1.5 meters away from the line AB. Everyone got that bit correct, so well done. It is at least 1.5 meters away from the line AB because you've got this huge area, with a width of 1.5 meters, okay? So, the next point says, the points that are closer to B than to C and are at least 1.5 meters away from the line AB. So this bit is correct. But let's have a look at the point that it's closer to B than to C. Okay, so let's take maybe this point over here. Okay, So yeah, you can see here that your set of points over here is closer to B than it is to C, and you've got this distance to be slightly larger. But if we take another extreme point, you can see that the points may not necessarily be closer to B than they are to C, right? So if I were to take, for example, this extreme point here, obviously the diagram is not drawn to scale. Yeah, so this was meant to be a bit more, it was meant to be a bit more exaggerated, but it isn't, unfortunately. So my apologies about that. But I can see where the confusion might come from. Yeah, essentially, make sure that you're choosing extreme points and you're trying to see if, each of the statements holds true or not. Okay. Move on to the practice questions. So question 10 says, construct a locus of points that are the same distance from points A and point B. Okay, so I'm going to give you about maybe 3 minutes to have a go at this question, and then we'll go through the answers together. Okay, 3 minutes is a bit long. Maybe 2 minutes is better. Okay, I'll give you 2 minutes. Okay, so let's have a look at the answers. Essentially, what we need to do is, okay, this doesn't show very well. Again, start off with your compass at the point A, with the pointy bit at point A, and sort of extend the width of the compass such that it's more than halfway away from AB. So you can guess, right, halfway would probably be around here. So extend it beyond halfway, and then sort of rotate your compass to draw an arc at the point about here, right? So don't draw the full arc because that would be, a bit long. Just make sure that you draw one right above, and then again, don't change the width of the compass, keep it the same, and put the pointy bit over here at B, and then without changing the width of the compass, draw another arc that goes like that. Okay, so once you've done that, do the same thing at the bottom of the actual graph. So you can't really see the bottom of the graph, but you would have something that looks like this, right? So you'd have one over here, one over here. Don't change the width of the compass. Do the same thing again, repeat from both points. So from here, draw one at the bottom. Draw one at the bottom of this side, and then from here, draw one at the bottom from this side. Then all you have to do is connect both of these points with a ruler, okay, and draw a nice long line through it. And this would be the locus of points that are the same distance from A and B. So you can see that we've got a perpendicular bisector, and yeah. So moving on, what does bisecting actually mean? Bisecting is a word that means that I divide something into two equal sections. So you can see here our apple is divided into two equal sections. When we divide a line into two equal lengths, we say that it's been bisected. So if I have something like this, probably straighter than this, and I sort of draw a line like that, and I say this line is equal to this line, I say that this over here is a bisector. It's bisecting my line into, two equal parts. Okay, so how do we actually construct a perpendicular bisector? You can think of this perpendicular bisector as an example. If you take a plane and you fly, and the plane flies an equal distance between two control towers, as you can see on the screen, the locus of the plane is actually the perpendicular bisector of the two towers. So if I were to connect these two towers, with an imaginary line, this plane's locus would actually be the perpendicular bisector. It would not only split this line into half, but it would also be perpendicular. Okay, so how do we actually construct this? We need to draw the perpendicular bisector of the points X and Y. And for that, first of all, start with a compass, okay? All you have to do is, first of all, place the point of your compass at X, and then open the pair of compasses as, once you've reached a point where your pencil is way past the half mark, right? Make sure that you don't go really, really close to the half point, because you don't know if you might end up accidentally going smaller than half. So make sure you try and exaggerate a bit, but it's not necessary to over exaggerate it. So yeah, we've got this over here, and then what we need to do is repeat from point Y, right? So don't change the width of the compass, keep it the same. Just move the pointy bit from X to the point Y, and then construct another arc of this sort. So you should probably be able to see my red dot just on the line. Then what we need to do is we need to connect both of these points with a nice straight line using a ruler. And I've not demonstrated that properly, I can tell, because my line is very wonky. Let's ignore that. And use our sharp pencil and a ruler to connect both the points, and this should divide XY into two equal lengths, and it should be perpendicular as well. So if you took a protractor, for example, to test what you've just done, your protractor should say that this line that you've just constructed is perpendicular to XY. Okay, so angle bisectors. Bisectors actually split up an angle now into two pieces, equal pieces, rather than, for lines. So you can see here an angle bisector actually splits up this little area here from this little area here, which is quite nice. Okay, so another slide 8 question. What scenario does this construction best fit? So we need to read each of the sentences and match up to the diagram. Remember, if I have a point and I have, I want to find the set of points that are equidistant, so let's say maybe 10 meters, that would be a circle. So look at it and see if how these arcs match up the description. And yeah, I'll give you about 2 or 3 minutes to think, and then I'll open up the Slido poll. Okay, so read each and every statement very carefully. As I said, even a tiny word change can make a huge difference. Okay, so let me activate the Slido poll. There we are, have a go. Just going to give you guys maybe a minute or so for those of you that haven't submitted your answers yet to do so. Okay, so let's have a look at what everyone had to say. Most of you said cow is tied to a 300-meter long rope at W, sheep is on the 400 meter long rope at Y, and we need to shade the area that they share. So that is the correct answer indeed. So well done if you got that correct. I'm going to quickly go through the answers. So let's have a read of the first statement, right? A cow is tied to a 400-meter long rope at W. If it's 400-meter long rope, then this over here, this arc over here, would actually have a diameter of 400 meters. This is 300 meters, so we can instantly cross out A. The next one, cow is tied to a 300-meter long rope at W and a 400-meter long rope at Y. We've got a sheep. Shade the area that they share. So it is the area that they share, isn't it? So the intersecting bit is the stuff that they share in common. Because the cow could be here, but the sheep could also be there because, you know, that's the region saying that this is where the sheep can be and this is the region where the cow can be. So both the sheep and the cow can stay in this little region there. So that's correct. Finally, let's read the last statement just to make sure that it's all wrong. Cow is tied to a 300-meter long rope at W. Sheep is tied to a 400-meter long rope at Y. Shade the area that they do not share. So that's not true, obviously, because the cow can obviously be in here and the sheep can also be in here. So that's wrong as well. So that's how we work out the answer for this one. Hopefully that makes a bit more sense. Yeah, if not, feel free to ask questions in the Teams chat. Okay, so we've got another exam question. Joe wants to bisect angle BCD. Here is his method. He uses a pair of compasses to draw arcs of the same radius from B and D. So he takes a radius, you know, he takes a point bit and B and he draws an arc of this sort, and then he goes to D and he doesn't change the width of the compass and he draws another arc and he draws a line through it. So we need to decide what is actually the error in his method. Now, the error in his method is actually that he's not allowed to draw an arc from here and then change the length from C and then draw another arc, okay? The points that he draws the arcs from need to be equidistant from C. So if he chooses this, he needs to find the equivalent point over here and then draw the arc. So you can see here the mark scheme accepts the arcs could be drawn from C or from points the same distance from C, or the lines are different lengths, so you cannot go from the ends. Okay, so that's the reason we said, and this is also acceptable. Okay, so Kay wants to show all the 3 points, all the points that are 3 kilometers away from point P. Here is her answer, and we need to tell them what is wrong with her answer. So I'm going to give you about a minute to think of an answer for this, an answer on your piece of paper, and then we'll go through the answers together. Okay, so let's go through the answers then. So our points that are 3 kilometers away from P actually need to be, it needs to be a circle, right, rather than a square, as they've shown. So we need to make sure that we mention that it should be a circle, not a square, or you could have also said that the corners of the square are too far away. So, you know, maybe this, whoops, what am I doing? Maybe this over here, you know, this might be 3 kilometers away, but this over here using Pythagoras wouldn't be 3 kilometers away, it would be longer than 3 kilometers. Okay. So that is the answer for that. Make sure to mark your answers and, you know, write down any corrections, because as I always say, the best way to practice maths is to, you know, keep doing exam questions and make sure that you're, you know, correcting yourself and trying to be as close to the mark scheme as possible.